So let's continue simplifying roots. So in the previous video, we were able to take the square root of just the basic numbers, like square root of 49, square root of 144. We even did a couple cubed roots as well. Now here we're going to do some problems that maybe cannot be as simple. For example, the square root of 125. Okay, so there's many different ways that you can do this. In the book, it does show a lot of different ways. But here I'll explain a couple things to do. So I'll show you the book way, and then I'll show you my way that I like to think about it. So one thing that you need to remember is that there are some properties of exponents. Basically, if you have x to the power of m times x to the power of n, well, what happens is that you take x and then you can add up the exponents. A good example would be x squared times x cubed. Right? So this will be x to the power of 5 because 2 plus 3 will give me 5. Okay? If you have x to the power of m divided by x to the power of n, because we added when we were multiplying, here we're going to subtract x to the power of m minus n. Okay? So those are some properties, property 1 and property 2. Okay? So one thing that you can think about is that, okay, well, is there something that will multiply the square root of 125. Well, there's a couple of things that you can do. Well, one thing that you can do is that I know that the square root of 125 is just 25 times 5. Okay? And I know that 25 is just 5 squared times 5 to the first power. Okay? So here what we can do, we can actually apply the square root to each individual. 5 squared and the square root of 5 to the first power. Okay, and this, well, the 5 squared is just going to be 25. The square root of 25 is just 5. And here we're going to have square root of 5. Okay, because this 5, you don't have a closed form of a square root. So this is going to be my final answer. So the book, basically what it does, it kind of separates it into different things. Now, this method is good. I use something completely different. So this is method number 1. You can do this if you'd like. If you don't like that method very much and it kind of confuses you, it's okay. Here's another method that I like using. So I'm going to put the square root of 125. Well, the first thing that I think about is I think about, okay, well, what number can 125 go into? Well, I know it's a 5. So if I divide 125 by 5, and this is where you want to use your calculator to like really start dividing numbers to see what goes into 125. Well, we know that that's going to be square root of 25 times 5. I want to further decompose 25. Well, 25 can be decomposed as 5 and 5. So I'm going to have square root of 5 times 5 times 5. Okay? So now, when you have a square root, basically what you're looking for is pairs. Okay? So how many pairs do I have in here? Well, I have one pair of 5s, and this one doesn't have a pair. So what I'm going to do is I'm going to take this one pair of 5, and I'm going to take it out. So that is one pair. So every pair is going to count as 1. So it's going to be one pair of 5, and then who stays under the house? Well, just this 5. This 5 is going to stay inside. Okay, so that's going to be my answer. Okay, so I like method number 2. It's not as mathy, but you can do any method that you like. Okay, so let's do another problem. Okay, so let's do an example. And let's say we wanted to do the square root of 500. Okay, so let's say if we want to figure out what the square root of 500 is. Okay, so what I'm going to do, I can use my calculator and I can try to divide 500 by 5 because I know that this is going to be into, or take into 5, divide into 5. So this is going to be just the square root of 100 times 5 because I know that that's how you can multiply two numbers to get 500. Now 100, I can continue breaking it up as 10 and 10. So that's 10 times 10 times 5. Okay, can I further decompose the 10s? Well, the 10s can be decomposed as 2 times 5. So that 2 times 5 is going to give me 10, that first 10. This next 10 is going to be another 2 times 5. And then I have another 5 left over. Okay, so I had this one that came from the 10, this one that came from the other 10, and then this one left over. Okay, and now what I'm going to do, I'm going to look at pairs. Okay, So here I have a pair of 2's. Okay, so here is one pair, which is going to come out. Okay, so that's going to give me a 2. That's one pair of 2's. Now what else do I have? Well, I also have a pair of 5's. Okay, so I'm going to take out this 5 out. That's a pair of 5's. Do I have any more pairs? I don't have any more pairs, so I'm going to be left with this square root of 5 at the outside. And what I'm going to get is just 10 square root of 5. And that is my answer. Okay, now you could have done the first method if you wanted to. You could have done square root of 500, okay, is equal to, and then you could have had, well, this is just 100 times 5. 100 can be 10 squared times 5, and then just did the square root. 10 squared, square root 5 is still going to give you 10 square root of 5. Okay, so you still get exactly the same answer. Okay. All right, now let's do something a little more complicated. Let's see if you want to try this one out. Whoops. Let's say you wanted to do the 5th root of 729. Okay, so if you want, you can go ahead and try it out. If not, then you can wait for me to do it right now. Okay, so the first thing that you want to do is that, well, I'm not sure exactly what 729 is, so what two numbers multiply to get 729. So one thing that you can do is you can use your calculator and you can start dividing a couple numbers. So you can take 729 divided by 2, and if you get a decimal, which you will, then that's not an even number that divides into it. Now, because I know that 729 divides into 9 evenly, I can just go ahead and do that. So this is going to be the 5th root of, if I divide this by 9, what I'm going to get is 81 times 9. Okay, that's what I end up getting, because 81 times 9 is going to give you 729. Okay, for now, you might not be really versatile in terms of just dividing out the number, so just use your calculator and just start dividing some things out. You can always use the square root function, but sometimes it might not. Sometimes it might work, sometimes it might not. Okay, so now let's continue decomposing. Okay, so 81 can be further decomposed as 9 times 9. That's going to give me that 81, and then I also have an extra 9. Okay, can I further decompose these 9s? Yes, I can. So this first 9 is going to be 3 times 3. This other 9 is going to be another 3 times 3. This other 9 is going to be another 3 times 3. Okay? Alright, now, here we're not looking for pairs. Here we're looking for fifths. So 5, a pair of 5s. Okay, so what I'm going to do is look for pairs of 5. So here is 1, 2, 3, 4, 5. So here is a whole set of 5. All of these are going to come out and party. Okay, so I'm left with, so this is one pair of 5 of whatever, right? 5 3s, and then who is left inside? So, well, just this one is left in the inside. Okay, and that's it. That's all there is to that. Okay, so these problems are not too terrible. I do like this method of taking things out, but if you don't like it, that's fine. I understand. So now that we feel a little comfortable with the variables, with the numbers, now let's do variables. Now let's introduce the alphabet, which everybody tends to get scared of. Okay, so let's say, for example, we have the square root of x cubed. Okay, now this x has 3 x's. Okay, so that means I have 1, 2, 3 x's. Okay, and because it's a square root, I'm taking out pairs. Okay, pairs of x's. Here is one pair of x's. I'm gonna take it out. Okay, so that's gonna be one pair of x's, and then I'm gonna be left with the square root of x. Okay, now do I have to add absolute value? Yes, I do, because I took out something from an even root. So if you go back to my notes, add an absolute value when you simplify even roots with variables. And even roots is a square root, that's one of them. So since I took something out of it, I'm going to have to add an absolute value right there. Okay, so that is my answer. Okay, so anything that you take out of this out of the square root, that's a variable, right? That's when you're going to add an absolute value. Okay? Alright, so now let's say we were looking at the fourth root of x to the seventh. Okay? Well, how many x's do I have in the inside? In the inside, I have 7 x's. So 1, 2, 3, 4, 5, 6, 7. Okay? Alright, so here we're looking for pairs of 4. Okay? So let's look for all the pairs of 4. Okay, so it seems like I only have one pair, 1/4, that has 4 x's in there. So I'm going to take all of these out. Okay? Alright, so I'm going to take out all of them. Okay? And all those losers in there, they don't have a pair, so they're going to stay inside. Okay? So these stay inside. Okay? And how many are they? There's 3 of them. Okay? Now, do I need to add absolute value? Yes or no? The answer is yes, right? I'm going to add an absolute value because it is an even root, right? And I'm taking something out, and I'm just going to apply it there. Okay? Alright, now let's say we were looking at this other problem. Let's say we had, I don't know, the cubed root of 16x to the 5th power y to the 7th. Okay? Alright, now initially we know that this is an odd root, so we don't need to add absolute value. That doesn't really matter. Okay? Now let's look at the 16. Let's decompose everything. Okay? So 16 can be broken up as 4 and 4, because 4 times 4 is going to give me 16. There's 5 x's, 1, 2, 3, 4, 5, and then I have 7 y's. 1, 2, 3, 4, 5, 6, 7. Okay, and this is a cubed root. Okay, I can further decompose this 4 as a 2 and 2, and this 4 as a 2 and 2. Okay, so here I'm looking for triplets. Okay, so I'm looking for triplets, so here's a triplet of 2, so that one's going to come out. Okay, no absolute value, so just a 2. That's a triplet of 2. Now x's, I'm looking for triplets too. Here's 1. Do I have any more? No, those 2 are just 2, so this one's also going to come out. So 1 triplet of x's. And then y's, I'm going to look for more triplets. So here's a triplet, and here's another triplet. Okay, so I have 2 y's. So I have 1 y and I have another y. Okay, so 2 triplets of y. Okay, and now what's going to be left inside? Well, I'm left with 1, 2. I'm left with 2 x's, and I'm left with 1 y. Okay, so let me write this a little bit better. And I have 2xy squared cubed root of 2x squared y. That's going to be my answer. Do we have to add absolute value? We don't, because this one was a cubed root. Okay? Alrighty, so I don't want to make the video even longer than what it is. I'm going to do more problems in the next video.